Hey guys, welcome back to chapter 16. In this video, we are going to practice predicting if a salt is going to have an acidic, basic, or neutral effect. Okay. So just remind ourselves of the steps. So the first step is to break the salt apart into its cations and anions. That way we can organize our thoughts and clearly see what we're dealing with. We're going to remove any conjugates of strong acids or strong bases. So remember, strong acid conjugates will be neutral, strong base conjugates will be neutral. So we can go ahead and get rid of those. Any metals with a +1 charge will have no effect on the pH solution. So that hinges on step 2. So both of these are really connected together. And then determine how the remaining ion will affect the pH. So I'm going to do these 3 with you, and then on the next slide, I'll give you a chance to do 3 on your own. Okay. So the first step is to break these apart into their ions. So we're going to break this apart into beryllium and fluorine. Okay. All right. So getting rid of, so break apart into cations and anions. Did it. Remove any conjugates of strong acids and strong bases. So now we have to ask ourselves, if beryllium was in a compound with a base, so it would look something like this, BaOH2, would this be a strong base? And the answer is yes, right? So beryllium is a group 2 metal. So group 2 metal with hydroxide would be a strong base. So beryllium is a conjugate of a strong base. So that would have a neutral effect. We're going to get rid of that. Okay. Fluorine. If fluorine were in an acid, fluorine would be HF. Is HF one of our big 5? No, it's not. So fluorine is not a conjugate of a strong acid. It's the conjugate of a weak acid. So this is going to have an effect on solution. So yes, it will affect pH. Okay. So now we need to decide how it's going to affect the pH. Well, that handy tool that we used, AB. So if this does have an effect, it's going to have a basic effect. Next one, silver nitrate. Okay, so the first step is to break this apart. Oops. Break this apart into its ions. So this ion is going to be silver with a 1+. This ion is going to be nitrate with a 1-. Okay. Step 1, remove any conjugates of strong acids and bases. Remove any metals with a +1 charge. Well, this is silver. This is a metal, and it's got a +1 charge. So if it has a +1 charge, it is not going to affect the pH. So we get rid of that. It's going to be neutral. Nitrate. Is nitrate one of the big 5? Yeah, it is. So if nitrate were in an acid, it would make HNO3. And what do we know about HNO3? It's a strong acid. Okay. So if we want to remove any conjugates of strong acids, this would also have a neutral effect. So if I put silver nitrate into a solution, is it going to affect the pH? No, it's not going to affect the pH at all. Next, we've got iron bromide. So iron is a 3+. Bromine is a 1-. Okay, so we broke it apart into its conjugate acid and base. We broke it apart into its ions. Iron has a 3+ charge. So is this going to affect the pH? Yes. Remember, small and charge of 3+ or more will have an effect on the pH. And using our handy AB model, this is going to have an acidic effect. Bromine. So if bromine were in an acid, it would be HBr. Is HBr, excuse me, one of the big five? Yeah, HBr is a strong acid. So this is a conjugate of a strong acid. It is not going to affect the pH. So that would have the neutral effect, or that would just be the counter ion or spectator ion. Okay, so if I throw HBr3 into solution, how is it going to affect the pH? It's going to cause the pH to become more acidic. See if you can do these three on your own. Okay, we're going to break this apart into potassium and sulfate. So potassium is a +1 ion. +1 ions or group 1s are conjugate of strong bases. So KOH is a strong base. That's going to be neutral. Sulfate, if sulfate were an acid, it would be H2SO4. That's one of our big five. So again, this is a conjugate of a strong acid. So adding potassium sulfate to solution will not have an effect on the pH. Next one is sodium and nitrite, NO2. Sodium is a group 1 metal. It has a +1 charge. It is also the conjugate of a strong base. So sodium hydroxide is a strong base. So again, +1 charged metal is not going to have an effect. That will be neutral. Nitrite would be HNO2. That is not one of the big five. So nitrite is the conjugate of a weak acid. So this will have an effect on solution. If we use our AB model, this will have a basic effect. Okay. So adding sodium nitrite to solution will cause the pH to become more basic. And last one, ammonium chloride. So this one's a little bit more difficult because we see this NH4 here. Okay. So ammonium, is it a group 1 or group 2 metal? Nope. Is it a metal in general? No, it's not really a metal. It's a polyatomic ion. So NH4 plus will have an effect on the pH. And so if we use our AB model, it's going to have an acidic effect. Chlorine, if chlorine were in an acid, it would be HCl. Is that one of the big five? Yes, it's one of the big five. So that's a conjugate of a strong acid. So this is not going to have an effect. It's going to be neutral. So adding ammonium chloride to solution will cause the pH to become more acidic. Okay. Please practice this skill. This is step 1 in a multi-step problem. So it's important that you can do this step quickly, and it's important that you can do this step accurately because it will mess up the rest of the problem if you don't. I hope you guys found this helpful.